Okay, so let's make a Python program to check if a number is a prime number or not. But before we start coding, here is a quick rundown of what prime number is. It's a natural number that has exactly two divisors, which are 1 and the number itself. For example, 7 is a prime number because it can only be divided by 1 and 7. On the other hand, 9 is not a prime number because it can be divided by 3, which is a number other than 1 and the number itself. Moreover, 1 is also not a prime number because it has only one divisor, which is the 1 itself. We need two divisors for it to become a prime number. Now that we know what prime numbers are, let's list a few examples starting from 2 and going on to 3, 5, 7, 11 and so on. Now in Python, first we'll ask the user to input an integer so that we can check if it's a prime number or not. Initially, we will assume the number is prime by setting a variable status equals to true. Since a prime number is only divisible by 1 and the number itself, we'll run a loop to check for divisors from 2 up to the number minus 1. So this loop will run up to the number excluding the number. After that, we check this logic. If number modulus I equals to 0, that means we are checking whether the number is divisible by any number from 2 to the number minus 1. If it is divisible, then obviously it is not a prime number. Hence, we write like this: status equals to false. So let's review the code again. Get the user input. Assume the number is prime by setting status to true. Check for divisors from 2 to the number minus 1. If any divisor is found, set status to false. If the status remains true, then it's a prime number. If it is not, then it's not a prime number. So you run it. 7 is a prime number. 9 is not a prime number. Now there is a small issue. If we input 1, the program says 1 is a prime number because the loop does not run at all and status remains true. But actually 1 is not a prime number. To fix this, we add a check. If the number is greater than 1, only then we run the loop. Otherwise, we set status to false. Now, if you input 1, you see it is not a prime number. And also, negative numbers aren't prime numbers because prime numbers are natural numbers. And now our program also works for that. Now we can optimize the code further. Instead of running the loop up to the number minus 1, we only need to check up to the square root of the number. This is because if a number is divisible by any number greater than its square root, it will already have been divided by a smaller number. To show what I mean, for example, 36. Its square root is 6. The divisors are 1, 2, 3, 4, 6, 9, 12, 18 and 36. Once you check up to 6, you don't need to check beyond that because any factor larger than 6, for example 9, 12, 18, would have already appeared with a smaller factor. So that's why we are going to run the loop up to the square root of the number. So in the loop, we will run up to number to the power 0.5 plus 1 to include the square root number. Now if you input a number like 7, you get an error. Well, it's because the square root gives a floating point number. To fix this, we convert it to an integer. And there you go, now it works. This optimization will save you a lot of time if you are working with a very large number. Now what if you want to find prime numbers within a range of numbers? Such that instead of asking the user to input a single number, we'll ask the user to input a lower bound and an upper bound and then check each number in that range. We use a loop to go through each number and check if it's a prime number or not. So we write for every number in the range of lower bound to upper bound plus 1. Again, the plus 1 is to include the upper bound. In print, we also print the number so that we understand which number is prime and which is not. Now you run the program, for example 1 to 100, and you see we get the information for all the 100 numbers. After that, you may want to count how many prime numbers are there between 1 to 100. To count the number of prime numbers in the range, we initialize a variable count to 0. And we will increase the variable value if it is a prime number. So each time it is a prime number, the count increments. Finally, we print the count. Number of prime numbers within lower bound to upper bound is the count. Running the program for a range of 1 to 100 will show you that there are 25 prime numbers between 1 to 100. So hope this helps you understand how to find prime numbers in Python. And as always, thanks for watching.